Yeah, Andy, hi, it's Anas. Can you hear me right now?
Hey. Yes, yes, can hear you. Can you hear us?
Yeah. So. Good. So, today's we have a workshop people about magic blocks, the ephemeral rollup, and I think uh, magic block right now that is a mm, very super technical, deeply for the people who want to work in the Solana right now. So yeah, so that is the reason why we have a workshop today. So hopefully our people in the Vietnam can see the how can we build with a magic block. And yeah, so let's get started. So I will let the stage for all you guys. So and after the presentation of all you guys, so we will have some questions about the topic. Okay, awesome.
First of all,
Yeah.
thank you, Min and Faye, for inviting us. We are so
Yeah.
glad to be back here with Super Team Vietnam. And Andy and I, we are super excited to share our new technologies that will unlock new potential on Solana and so many use cases. And I will give it to Andy to share today and the details.
Awesome.
Yeah, for sure. Yeah. So if you guys don't know, so my name's Andy and I'm a DevRel at Magic Block. And joined with me today is also Jonas, the other DevRel at Magic Block. Again, yeah, thank you very much, Super Team Vietnam, for having us and letting us join this technical sharing session. We're here today to primarily talk about our new privacy features that we just released literally last week. We're super excited about it. Um, if you guys are unfamiliar with Magic Block, a quick introduction is that we were started in 2021 by our founders, Andrea and Gabriella, while they were making fully on chain games on Solana. And that's where I initially met them. I was actually one of their first customers using their Unity Solana SDK. But while they were building these on chain games, they realized that Solana block times couldn't really fully handle these games just because, uh, maybe like the block time is 400 milliseconds, the fees are a little high if you need to do stuff like every single second. So they actually built the concept of ephemeral rollups. And it turns out that a lot of other use cases also want these ephemeral rollups. So today, what I sort of want to talk to you guys about is, why Magic Block, how Magic Block works, TEE, and then hopefully give you guys a quick demo about some of our technologies. So first things first, why Magic Block? So for fully on-chain applications, 400 millisecond tick times are just a little too slow. So this is actually on the screen one of the teams building on us, Supersize, who actually won the gaming track of the Solana Radar Hackathon. So they chose to build with us because there's essentially no other options available for the vision that they wanted to build. So if you look at this example on the left, it would be, I guess, if their application was on Solana, where there's every 400 milliseconds, there's a tick of activity. However, on the right is their live application. And in this example, all the moves and the state is full user position, your user size, everything is fully on chain. And they even have multiplayer. So by using Magic Block, they coordinate the state of up to 100 players, all on the same map. And I think they actually recently rebranded to Slime Coin. You guys should check them out. It's free to play, and it's like every blob you eat is a little coin that you get. Um, so there's like a ton of app benefits to building these fully on-chain applications, especially on Magic Block. So here's some of the use cases that we're seeing being built. For DeFi, you have verifiability of assets and self-custodial funds. You can check to see that all the funds that are supposed to be there are still there. And having faster block times means that you have much faster liquidations, not just faster, but better liquidations and less risk involved. So a common thing that people say about this type of stuff is that uh, because when you have faster block times, the market makers on you, they get picked off less often, meaning that they lose less money. There's less toxic flow, and therefore they can give better prices. And if they can give better prices, that means that it's a better spread from consumers, and consumers lose less money. For games, you have stuff like persistence of state, composability of assets and permissionless extendability. For example, say like you create a game and anyone can make an arbitrary dashboard to maybe verify the supply of rare items to make sure that it is what the game developers say that they are. The drop rate is what the game developers claim it is. And we're seeing a lot of people use this to also build dependent AI. Uh, Actually, one of the teams currently building on us, I think, is doing something really cool. So they're doing on-chain inference. And what that means is that they're actually streaming every single token of a query through an account. So what that looks like is that, say, I send a query out and I'm like, what are the best restaurants in Ho Chi Minh City? And the query is sent to a queue, and the response is actually streamed through an on-chain account, one token at a time. Similar to like how ChatGPT gives you back one token at a time, they're doing this fully on-chain. And they're also utilizing our new privacy feature of the TEEs, because obviously you don't want like your queries and the responses to be public. And that's important for a lot of their use cases, like they're doing stuff with like education, healthcare. So that's actually a great use case for these privacy features. So in a way, Magic Block offers the best of both on-chain and off-chain applications. So for these off-chain were like hybrid applications, let's say, like if you guys are familiar with Off the Grid, very popular first-person shooter game, or it might be third-person shooter, but essentially most of the game is off-chain, and they have their assets on-chain to be traded and to be used to be sold on marketplaces. FTX, famously very off-chain, led to like not left to a big hole of the assets because it wasn't able to be verified, and centralized apps. And so the benefits of building sort of these off-chain hybrid stuff is that you have like, it's very performant. There's a ton of infrastructure around this already. It's extremely cheap, like an AWS server handling millions and millions, even billions of traffic is going to cost you like $100 a month. And it's very scalable. Like this is like a very well solved problem. There's like edge nodes around the world, like your stuff is propagated throughout a global CDN network. It's very well documented. And on the other hand, building on-chain gives you the benefits of composability, verifiability, and ownership. And these are some of the benefits that we talked about earlier, where you can build together with other things. You don't need permission to build on top of whatever you're building. And you can very easily have ownership of any items or any equipment on-chain. So Magic Block actually is able to provide both of these features, or all the features above, in one application. So on top of these features that we provide, we have a ton of these plugins for your dApps. So all of these are native to Magic Block. And so we have price feeds, PIF price feeds for every 15 milliseconds. You can get super low latency updates. We have cranks for scheduling transactions. So like, say you made a on-chain game, and every hour you want to start a random event automatically. We have the infrastructure for you to be able to do that. And this is similar to, if any of you are familiar with Clockwork back in the day, just scheduling it such that you don't have to have a off-chain scheduler to send these transactions for you. We have a high precision millisecond clock account. So currently on Solana, if you want to try to schedule something via a clock account, it's in seconds, which is a very interesting design choice because like even Solana's inherent block times are 400 milliseconds, right? So the level of accuracy provided is not super high. I actually do think that they recently submitted a PR to change it to milliseconds though, so that's great. We have oracles for randomness and AI. So if you want to generate any kind of random numbers for your application or use AI for some on-chain inference, say that in your game, you want to have the NPCs be able to have like custom dialogue with players, that's possible. And we also offer custom fees. So that could mean if, say, Pump Fund was built on a ephemeral rollup, they could take the native gas fees of the chain in Pump token, or it could be fully customizable for any team. And so here, you can see some of the different teams in our ecosystem. So we have integrations with, like I said, Supersize, Flash Trade, D-Telecom, which is a DPIN network, Cbit, which is a casino, and Pith, which is a price network. And the reason why a lot of these teams choose us is just because our cost is way lower. We're 40x up to 40x faster, sometimes even more. And now, most recently, we're offering private transactions to be able to be done. So I'm going to quickly dive into a little bit of the high level how it works. So what is Magic Block? So Magic Block can claim to be the original Solana network extension. We're offering 10 millisecond block times in a gas-free environment, and we have global state infrastructure and composable dApps. But sometimes it's actually a little hard to explain, at least to a lot of people at first sight, what Magic Block is. So I'll take you guys through a conceptual example. So imagine that this is the Solana base chain. It's great, and it's much better than its competitors. However, there's a speed limit of 400 milliseconds, constrained by the fact that they need to do consensus across the world. So this is great, but some people want to go even faster. So internally, how we think about Magic Block is it's sort of like a highway for these accelerated transactions. So while on Solana, every 400 milliseconds, a block is produced. The blocks on Ephemeral Rollup are as fast as 10 milliseconds. So you're kind of driving on a highway in parallel to the main road, which is Solana, but just much faster. And eventually you will get off the highway and back onto the main road. So in order for any transaction to be executed in real time, these accounts need to enter and exit the highway. And how does that work? So it works through a system we call delegation. So Magic Block utilizes delegation. Before transactions can be accelerated going on the highway, the account needs to be delegated. And that means the ownership of the account needs to be transferred from the original program to the delegation program of Magic Block. Afterwards, transactions that are usually submitted on Solana, the base chain, can be submitted without any changes, just directly to the Magic Block RPC and executed in real time. So that means that changing your program to use Magic Block to use this highway is super simple. After you get on the highway, everything remains the same. And then on demand, these account state changes can be committed back to Magic Block. So exiting the highway by undelegating or transferring the ownership from the delegation program back to the original program. So here's a nice little diagram sort of showing what I mean. I'm not sure if you can actually see my mouse here. Oh, you can, perfect. So you can see that in one block, when we delegate out, it delegates the account state to Magic Block. And so on the Magic Block chain, it syncs the main state. It syncs the state of Magic Block to the main chain as fast as every single block. If you wanted to, you can sync every single block back to the main chain. And these validators commit optimistically the state from the ephemeral rollup back to Solana. And anyone can challenge these state commits with a proof also to reject the state. So here's an example of it in action. So on a given block in the main chain, so like here, you delegate to the ER and you see that there's a ton of blocks happening. And then when you're done, you undelegate back to the main chain. So an example could be that, say you wanted to play a chess game and you wanted to play like a bullet chess game where every second matters. You delegate here at the start, it goes to the ER, and you play the game super fast, like you're making like rapid moves back and forth. And at the end of this game, when a winner is decided, you undelegate back to the main chain, and the state of the game and all the moves and all the transactions you made, you can know and you can keep. So this way, you're able to essentially stay on Solana while getting the benefits of these faster block times. So all you need to do to implement this is to just add two simple functions to your code. Don't worry too much about like the actual technical code here, but the idea is that all you need is a delegate and a undelegate function. So this is an example of doing it both in native Rust and in Anchor. And we're hoping to support Pinocchio very soon for those Pinocchio enjoyers out there. Another thing we have to make the developer experience better, we recently released something we call the Magic Router. So normally when you're using Magic Block, you actually need to keep track of the state. So whether the program is currently delegated or not. So that you can know whether to send your transaction to the Solana RPC or the Magic Block RPC. So like back in the chess example, you need to know whether you need to submit your move to the base chain or to the delegated chain. So what we did was that we actually created a router where you can send all of your transactions to, and based on the metadata of your transaction, we'll be able to route it to the correct chain. So like right here, before you have to decide, like you have to, in your program itself, you have to keep track of where it's currently living and then either send it up to the magic block or down here. But then now there's a router abstraction. So under the hood, what we're doing is that when you send a transaction to our router, we're checking the metadata of the transaction to get the writable accounts. And after getting the writable accounts, we're checking to see if all of the accounts are delegated. And if so, we route it to the ER because we know that, oh, everything is delegated. And if not, we route it to the base chain. There should never be a transaction where you have both delegated and undelegated accounts. So that's just an error state. So real quick explanation, same thing. This is the life cycle of a delegation. So from delegating, it delegates, and then it does real-time execution, committing the states. So you still use Magic Block in exactly the same way with the Magic Router, where you can commit and you can undelegate. Note here that so the block times that we state here, the 10 milliseconds, 400 milliseconds, the latency here includes not only the block time, but in real world, it will include networking delays just from the internet itself. Here, I guess our quick little overview of some of the fees we charge. So for ER fees, a session, which includes delegation and undelegation, costs 0.003 SOL, and then each commit costs 0.001 SOL. And I guess how we actually charge it is interesting because when you create a delegation, you need to pay a certain amount of rent. And the fee is actually charged by when you undelegate, we withhold sort of the amount of rent or the amount of fees that you incurred from the rent that we refund. So it essentially comes back to you as like a deposit. So on the public ER, it's gas free. There are no transaction fees. And on a dedicated ER, if you want a ER specifically for your team or specifically for your project, we're 10 times lower than the price of mainnet. However, something important to note here is that the mainnet price here doesn't include priority fees, which is necessary for a lot of these transactions on mainnet. So you're looking in reality from anywhere from like 10x to 100x cheaper than mainnet for these dedicated ERs. I guess something to note here is that most people won't and probably shouldn't use dedicated ERs. The people that we're seeing use it are for like super high volume projects where they just want to make sure that it's all their stuff, or actually for permissioned entry stuff. So like we're talking to like Dexes or Sexes building on us where they want to make sure that everyone that enters their exchange is KYC'd and they don't want any sort of commingling of transactions between KYC'd and non-KYC'd users, which would be why they wanted a dedicated node. But for most users and most apps, the public ER is perfectly good. All right, now let's get to the meat of today's presentation, our new trusted execution environments. So what is a trusted execution environment? A trusted execution environment acts as sort of a vault inside of a CPU. Generally, when you run a program, and I'm not talking about Solana programs, like any programs, like could be Google Chrome, could be like League of Legends, could be a validator. The operating system of your computer can see and influence everything inside, the code, the state, and the memory. So a TEE creates sort of this hardware secured space that physically prevents interference, even by the machine it's running on. So the TEE we use is actually called Intel TDX, which is the latest generation of TEEs. So there is an inherent trust assumption when you use the TEE here. And the trust assumption is that you trust that Intel made a good product and that their product is secure. But there's no real other trust assumptions besides the integrity of the TEE itself. So we use the TEE to actually protect the entire state of an ephemeral rollup. So normally when you execute a smart contract on chain, every step of the process is visible to anyone. Any observer can see what program your transaction is calling, what accounts you're calling it with, and what the subsequent state changes are. Using the TE, we can selectively shield the state of the ER. So if you look at this diagram, the TE essentially is the big box around everything. And there's an authentication layer that I'll explain, go into more detail about later, that protects what state a user can access in the ER. So that means that for any arbitrary program, you can't just like look at the state. You have to be permissioned to see this user is allowed to see what are the contents of this account. So I mean, a lot of times we get the question of like, why TEs? There's a lot of these privacy solutions out there on Solana and in crypto in general right now. So like there's fully homomorphic encryption, there's zero knowledge proofs, there's multi-party computations, and they're all powerful tools, but they all each come with trade-offs. So like the trade-off for TEs is like, you're trusting the vendor hardware, which is Intel TDX for now. And FHE, it's a little slow. ZK is very computationally heavy. And NPC, there's the high computation overhead. And they all have their uses for specific use cases. But we chose TE as our solution because it offers the most practical benefits for us. So it offers confidentialities, it offers really fast performance, and developer friendliness. You don't have to learn any different languages like you might have to do with FHE. And so it's something that builders can utilize today. So why should you use an ephemeral TEE? So it is confidential. The state is protected from all unauthorized parties. It's scalable. It runs inside an ER, and it can execute blocks at very high throughput and low latency. Throughout testing, we're looking at blocks coming out around like 80 to 100 milliseconds, which is slower than our generic ER, but much faster still than essentially every other solution out there. It's composable. You can interoperate with other Solana programs in the same way, and it's compliant. And it's easy to enforce these compliance due to we have a fine-grained access control layer. So TEs unlocks entirely new categories of applications. So things that literally could not have been built before. So like confidential transfers, you move these assets privately without exposing balances or the counterparties. You could do sealed bid auctions where you can enable fair price discovery by keeping bids hidden to a settlement. So it could be like, oh, I want to sell this with the recent Pokemon card stuff. So like say, I want to sell this super rare like PSA 10 Charizard. But under traditional bid auctions, you're actually usually not getting the best price because the person that's willing to pay the most for it doesn't have to pay what it's worth to them. They only have to pay slightly more than the second highest person. So this, by keeping the bid sealed, you enable this fair price discovery. You enable private games supporting use cases like poker or strategic games where revealing the state undermines the gameplay. It could be stuff like Risk. And then enterprise and compliance flows. So what that means could be like, say you're a company and you want to pay all your employees on chain, but you don't want everyone knowing what literally everyone else is paid. So you can run payroll, you can do like supply chain operations, or just regulated processes where while keeping these blockchain guarantees. Okay, so let me give you guys a quick demo. Unfortunately, it's right now our TE server is under maintenance, so I'm unable to show you exactly what it is, but I can show you sort of an idea of what goes on here. Let me share my screen real quick. Da, da, da. All right, Min, would you be able to present this new screen?
What's great?
I presented another screen, I think.
Okay. Do you see the plus, like the icon plus, the present in the picture?
Yes. So I see it I believe it's presenting, but I think you might have to say like drag it to present on the main stage.
Oh,
Um,
let me check.
yeah.
So, yeah, let me check. I can share screen right now. Hmm. I can share screen right now. So at, at your side, you cannot share the screen, right?
I think it's actually already sharing, but it needs to be sort of brought up. Let me try again. 1 second then.
Yeah. To be honest, right now, I do not see your screen is sharing.
Okay, 1 second.
Yeah.
Okay, so I clicked present and I see the screen being shared. It might be
Oh,
like a StreamYard thing where since I'm not the presenter, you need to sort of bring it to the main screen.
so let me check because like um mainstream, right? So let me ask you again because like I do not have any permissions on this account. So
Yeah, yeah,
yeah.
no worries, no
Okay.
worries.
Okay.
Mhm. Yeah, I mean, so while we're here, can talk about uh recently actually there was the Solana mobile hackathon. I don't know if you guys saw. Did you see that, Jonas? The Solana, what was it called? It was done by Radiant Style. It was it just literally was there a name for it besides mobile hackathon?
I think it was just Solana Mobile Hackathon.
I see, I see. Did you see it that there were actually a bunch of teams that were built on Magic Block that won this hackathon?
Yeah, I've seen
It
a
was
couple
the
of games we're building on us, right?
Yeah, yeah. Like there's games like the Block Stranding where you're going around and I mean they're trying to build essentially the first real fully on-chain MMORPG. They have like a lot of multiplayer done right now. They've actually integrated a lot with like AI, like Send AI, super cool team. I also saw there's another one called I
Crypto
think there's like
Fantasy League.
yes, Crypto
Our
Fantasy League.
CFI
They
guys, yeah.
yes, yes, yes. I love them, love them. They're building this. It's essentially like fantasy sports, but you're betting on these tokens. So it's like in the same way that you would build a fantasy football team, you build a team of fantasy tokens. Uh, I think they got an honorable mention mostly because I think you're not allowed to win if you've raised outside funds, and they actually raised they won the Solana. What was the major hackathon right before this? They won one of the Solana hackathons just
The
recently.
Colosseum one, the breakout.
Yes, yes, they won Coliseum. So they went to the incubator. I think they're currently going through that. So I assume that's why there's no pricing available there. But super cool, guys.
I find exciting that we unlock so many new use cases and precision for our projects that are building on us, like CFL, block stranding. I think it wouldn't be possible on chain at all to run like block stranding real time with every movement
Exactly.
tracking that, and CFL like the pricing. Yeah, so it's awesome to see that projects are using us to really unlock new benefits and better propositions that has never been there before on
Yeah,
on chain on Solana.
for sure. And especially with like there was another one, Celio. I don't think they've integrated us yet, but we're talking with them because what they want to do is they want to do these small micro payments across Nigeria. And the idea is that with on-chain accounts, the cost of rent for the account is actually high enough such that I believe like a cost of creating this like new token account is like maybe like 50, 60 cents. But that's actually high enough that because they want to do such micro transactions between people, even literally say like 10 cents, 20 cents, that is actually a prohibitive cost when you get to like a million, 10 million accounts. So that's why actually they're exploring Magic Block for creating and storing this state account on chain or on the ER. Hey, Min.
Okay, so just a quick update because like I think like I just thinking about my sharing, but to be honest, I cannot share the screen in the main state. I think like that is a screen error right now. So yeah, to be honest, like I cannot fix that.
Okay. Yeah,
Yeah,
no
yeah.
worries, no worries. We can just sort of let me see what we can do here. I wonder if I can sort of present it almost directly from my webcam. Uh let's see, let's see. So You guys are gonna have to bear with me for a second here as I try to get this up. I wonder if this will work. Private payments. Da, da, da.
That's fun.
Or yeah, no. I mean, sometimes we
Wonder,
we
yeah. We need to be creative here.
oh hey Faye, how's it going? I'm hopefully looking to get my screen shared here.
Worst case is the audience needs to wait for another session with us.
Yeah, exactly. You're stuck with us for a little bit longer.
You just got the teaser, You won't get the full package yet. Or people would think, oh, there's no TE actually, it's all made up. This is like a planned error.
Yeah, I mean, for any of the audience, if any of you, see us, if they're, I believe that Jonas, you're going to Solana, the Apex in Singapore, right? You're going to be there.
Yes, we will be in
Yes.
Singapore. A couple of people from our team will be there, and we are super excited to meet you guys. I mean, there will be a lot of events, side events, the main event, also token. Yeah, is somebody going from Vietnam? Really, really awesome if you are also there and we can catch up.
Yeah, for sure. All right, let's see if I can get this up. Let me show you guys. Ooh. So I wonder if I can send a link somewhere. No, it doesn't look like I can, but
We can share it through X. You can send it to me in the group and I can share it on X.
that's true. Oh, I actually don't see. So this is currently streaming on X, correct? Yes, I see it. Very cool, very
Okay.
cool.
Yeah. You can also send it there if you find it.
All right. This is a bit scuffed. All right, let's see. Oh no, the AI crops it out. It knows that it's not a face. Oh, okay, there it is. Okay. So guys, this is a demonstration. Don't take the UI as is, but this is a demonstration of VRF. Oh wait, can you? Is it being? Huh, interesting. All right. So the idea is that you can roll for a on-chain character. You can't see very well, but if you check my profile, you'll be able to see it actually. But the idea is that you're able to get fully on-chain randomness. And using this randomness, we generate these stats for these different characters. So by using this VRF, we do a cool trick where when you get randomness, you get like sort of these 32 random bytes. And without having to request randomness 3 times, using the same sort of shred of randomness, we're able to get all 3 stats and all the random things we need from that one shred, as opposed to having to sort of call it 3 times and making it slower. But yeah, very cool stuff. Check it out. Um, let me
The
see.
audience has, if the audience has questions about anything that Andy has shared, we are on X, so you can put your questions also there, and we are more than happy to answer them.
Absolutely. I mean, all right, Jonas, if you were a random person, what questions would you have about Magic Block? Let me enlighten you.
Why is it called Magic Block?
That's a good question. Actually, I don't know. Like, why is it? I guess it's like, yeah, because like our whole theme is like wizards and stuff like that. But like, I guess it's like it feels like magic. You know how fast each block is. Yeah, that's a good question.
Actually, I forgot. I think the founders, Andrea and Gabriel, they mentioned it, but
Yeah,
because
yeah. I mean,
initially it was even called Magic Block even without the Ephemeral Rollup, right?
that's true. You're no, you're right. They were called Magic Block even when they just had the the what's it called?
Old framework.
They started with a Unity SDK. That's what they started with. Yeah, that was their first product. And then I don't know if you saw there was a game called Kamikaze Joe, and it was sort of like an
What,
on-chain game of tag.
what was actually first? Like, was it Bold or was it Unity SDK? I wonder. I
I think
forgot.
it's Unity SDK. Because I think they
Um,
released both. Oh, actually, no, no, no. Maybe you're right. Maybe you're right. Unity SDK was definitely the product I knew them for, but maybe Bolt was already released by then. Hmm. I mean, this is way back. We're talking like yeah, like 2021. Like yeah, this is around for a long time.
a long journey. Yeah, that's true.
Yeah.
What is the question that you have in mind if you would be new and as random stranger meeting Magic Block and hearing about this now?
Yeah, I mean, sure. Okay, we'll switch roles. All right, Jonas. Tell me about tell me about it yourself. Tell me a little bit how you ended up at Magic Block.
Is this your first question when you're here? I mean, this session. I don't believe you.
You know how it is. Yeah, I'm just really interested in people.
Yeah,
Yeah.
hey, my number is not free. Okay, if you wanna go on a meeting, we can do it outside. No, just kidding. Just ask me. No, no,
All right. Let's
just kidding.
see. All right, Jonas. What tell me about a cool project that you've seen on built on Magic Block.
Cool project. I think one of the coolest project is Zebit. I think this is one of the ones that I mean they by far have the most transactions right now on the Ephemeral Rollup. I think is it a couple hundred thousands in a month or something at least,
Yeah.
or even million. Yeah, basically they're like I mean an on-chain basically platform of different games that you can play. So you can bet on different things and play like some kind of like a casino-like app. And the UI is awesome, like super smooth experience. And what you can do is basically you deposit some money, similar what you would if you would do it on in a casino. You exchange it, and then you can use these chips to quickly like put in every machine to kind of play around. And this is basically what you can do on Zebit, but all on chain and digital,
I
and
understand that
it's super
like
fun.
I see. Have you played it, Jonas? Have
Yeah,
you
yeah, play
won or
different.
lost some money on
I
Zbit?
lost I lost so much, yeah. But it's fun, you pay for the fun, right? You pay
Yeah,
for
yeah, yeah.
for the UX also.
Yeah, I mean,
Yeah,
it makes sense, like are casinos legal in Singapore? So like right now I'm in Hong Kong and
yeah.
people go to like Macau and stuff to do gambling.
I think
Yeah,
yeah, I think there are dedicated places or licenses for that. What I
I
find
see.
interesting about Zbit is also that they also use our VRF for the different because it needs to be random, right? A casino cannot be like I mean it's calculated risk also in some form, but in some form also random. But yeah, so it's cool also to see that Zbit is using our VRF, and yeah.
Yeah. Something I recently really liked is have you seen Rush Trade where it's very similar to like the tap to trade stuff where the line is going through and then you have to click to try to predict where the line will
Oh
hit.
yeah. That looks fun too. I haven't
Yeah, I
tried
think
yet.
you should try. They recently released a I think that they've had like a soft launch recently where you can try it out on DevNet or honestly, maybe even mainnet. I forgot, but it's live. Like it's using Magic Block, and every transaction you click, and it gives you a multiplier. So it's like, say, like you click a little small block, it'll multiply your money by like 1.5, 3x, whatever. It depends on sort of how far you are from the current price. So it's like the further in the future you're predicting, or the more out there boxes you're predicting, the higher your payout is. No, it's super cool. It's like you literally just use your thumb and you like tap 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 tap, and it's like such a fun way of trading, trying to predict this price as it moves. And it's cool because they use our on-chain price oracles with
Yeah.
this like PIF laser, so you're getting like very accurate prices. You're getting like 50 millisecond prices. And it's cool because when you pay out, you can deterministically prove that like they didn't cheat you. Like you can check the block on chain of like the time that they paid out, and you can check that they didn't like nudge the price a little bit to like make it
Yeah,
easier
yeah.
for them. Yeah, it's
Is
super
this
cool
your
stuff.
favorite? Is this your favorite
Uh,
one?
oh, perfect.
Oh
There
yeah,
it
it's
is.
back. Oh my gosh.
Yes. Okay, guys. All right. So, thank you for that, Min. So for private payments, this is what I was talking about. So actually, like I was saying, our server is currently down right now, but I can take you through it. So you guys can also check this out yourself on our, by yourself, and you can find it on the Magic Block Discord. So something cool to notice is here on the bottom right where it says verified, right? And so what this verified means is that it's actually an attestation that the website that you're interacting with and the machine that the website is interacting with is a valid TEE machine and that it has not been tampered with. So what we can do for private payments is that first you can create a token. And
Just one
so
joke. I mean, everybody can put a UI there and say it's verified.
yeah. I mean,
Right?
for sure, for sure.
But how do you check if it's really verified, Andy?
Yeah, so what actually happens is that you sign a message to the Intel TDX chain. So what happens is that you go in, you sign a message, and they, inside the TE itself, also sign and send you back a proof. And when they send you back the proof, you can verify that the machine that signed it is indeed a valid Intel TDX machine, and it is like not been tampered with.
You can see
Um,
it in the inspection, right? When you inspect it, I think there's like a request. And for you guys, if you wanna check the details on the proof.
yes. And so here we see that all you'd have to do is enter a recipient address and send them some tokens. So right now, again, it's going through some maintenance. So it's an internal error, but you can probably definitely check it out tomorrow. But what happens is that you will not be able to see the balance of the tokens of whoever you're sending it to, on top of whoever you're sending it to not being able to see your balance. And you would normally here you see a star star star, but yeah, private payments, it fully works on chain. It is something that we think will unlock a lot of use cases for teams, and have been in talks with teams already about sort of integrating this flow into their thing. um, I guess while we're here, I can also give a quick demo about some of our
Mhm.
other products.
One
So
one
this is
thing
what
I maybe
oh, go ahead.
maybe we should mention also on the private payments. So if you can go back, Andy, is
Mhm.
like this is just for transferring tokens, like SPL tokens, like any SPL token. It could be USDC, it could be any token. Here we are creating basically fake tokens, and like with the create token button to kind of like play around with and use it for the privacy, like applying the privacy feature on this. But what you actually can do for all the builders here out there is you can put anything on the ER. It can be a SPL token. It can be a customer account. It can be game logic. It can be or like not the game on logic only, but also data in general, right? You can put on the private ER, and I think very exciting is that the potential can be used for many use cases that we use Web3 and Web2, where we kind of like want to shield the data, customer data on AWS servers or whatever like servers we put on. But in this case, we can put everything now on the ER in a trusted execution environment and decide what can be seen, cannot be seen, and unlock so many composable applications that are on Web2, fully like on chain, while having real-time performance, while being composable and everything else, like really merging the two benefits of both worlds. Yeah, I just wanted
Yeah,
to mention that.
absolutely. Like Jonas said, like anything, like I said earlier, it's like you can have like a Pokemon card and have an auction on there. Like anything you want can be private as long as it's on chain. Actually, in the interest of time, let me talk to you. I'm going to present back to our presentation here on. Sorry, Min, if you could drag that
Okay.
up.
I think it cannot because like Faye need to Faye is a host. I just like a member like all
Oh,
you guys.
oh no, oh
No,
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 I see.
noise, noise.
Oh
Okay,
no,
so
oh
but I have
One
a
one
question.
thing
Like
sorry,
yeah,
yeah, go ahead, man.
okay, so I have a question because I just see the private training zone, right? So uh as I know that in the 2023 our have team handle the private training zones like basically like they have a pool, so all the fund will be visiting the pool and take back from the pool. So how how the Magic Club handle the private training center here? That is the thing I did not clearly understand because you say that even though I send transaction to another address, so I cannot see the balance. So how can balance have been? So the balance is empty or something like that. Yeah, just explain the thing in there.
yeah, no,
Yeah,
that's a great
hello system.
question.
Yeah,
So the question you're asking is like, how essentially does it work without sort of like there being an intermediary pool or some sort of like mixing happening? Is it able to be kept private?
yeah,
So that would have to do with our authentication layer. So there's a diagram, but I can just tell you about it, where essentially you define which specific accounts you're able to read. So actually, I can't show you here, but on the base layer, say I have a program and I want to define, and this is like a payment program, and I want to
yeah,
define only this wallet can read this. So like right now on Solana, if you go to Solana Explorer, right, you put in any account, you can see the balances of like account, you can see the transactions that account has made, everything. However,
it's like
inside a TEER, we're able to shield that. So by default, everything is actually still public. However, when you specifically define programs and associated token accounts of that program, you can define, say, I want Jonas's wallet to be able to only read Jonas's token. I want Jonas's wallet to be able to write to these accounts. So you define these read-write accesses. So when I send you a transaction, so say I send you 100 tokens of USDC, someone else in the future, one, they cannot tell that you have these 100 tokens. And two, when you spend these tokens, they cannot tell where these tokens come from because they do not have sort of the read access to the transaction history of your accounts. So it doesn't operate, say, traditionally like this sort of mixer where the funds are commingled and such, so you cannot trace it. But actually, it shields it at the most fundamental level, where you cannot even trace any sort of like account, any sort of I guess viewability of the tokens.
Maybe also let me add on the explanation that Andy made just now. So if you have this visualization of public mainnet, Solana is public, right? You can read everything, every transaction that is there. You can see the account, the balances. And then you have this ER, which is like also public by default, right? ER, where you delegate an account, and then on the ER, the transactions will be processed in real time, right? And with near zero fee, right? But now what we do is we add on the ER this shield, this TE with an authentication layer. So now imagine, oh shit, the ER is now private. I cannot read everything anymore, but I can still submit transactions, and the authentication layer basically will allow you to read or write or not. And then the ER layer will process the transaction as it would be processed on the public mainnet, but faster. So let's imagine if you don't have the account balance and you want to make a transaction to subtract, then on the ER it will give an error because under normal Solana logic, it wouldn't process, right? If your account has enough funds and the transaction is a valid one, right, then it will process everything and return a result back. But then the user can only read it if they have the right permissions through the authentication layer, which is in front of the ER, but inside the TE.
I see. So basically, like the logic will be handled in the ephemeral rollup, it not handled in the like base layer, right? Okay.
Mhm.
So
Yeah.
okay, so here is the thing because like to be honest, I also try to handle the token transfer in ephemeral lab and ephemeral maybe like 2 months ago if I choose. So and I know that to handle the logic in the ephemeral rollup, the magic block need to um, clone all logic about the token program, about the account, handle the transfer. So basically, it's like if have any error, like some error, because like even though if the magic block clone the token program, yeah, let's say I send Jonas 100 token USDC. So when undelegate back to the minute, how the thing is that verify, okay, if the we should calculate about the token transfer is not correct or not, something like that. So that is the thing I am very considered about security.
Yeah. So if, for example, there was only one person doing it, so this is in a similar way of like mixers, you can actually perform these timing attacks of like, oh, this account went in to the ER with 100 tokens and then came out later with 100 tokens. And so you can sort of link these accounts, right? However, the benefits of these kind of things is actually similar to as you have more people go in and out, as you have, say, like, instead of one person, you have 100, 500 people in the ER, then it operates actually more closely to this sort of idea of a mixer. Uh, Mixer is not quite the correct word. It's like a commingled pool of funds where you go in and these different accounts, all these transfers happening within the ER, and then when it comes out, it sometimes it'll have like say more, sometimes it'll have less. You wouldn't really be able to tell. And so there's actually a team that we're talking to right now that's built something very similar where they have the benefits of privacy while within these ER and by enforcing the amount that you go in and go out with. So like say you enforce that the account you have to go in with say 50 USDC or 100 USDC and you leave in set amounts as well, then you're able to sort of keep this privacy layer. You're able to keep this plausible deniability. Of course, we don't condone sort of, I guess, mixing of funds, and we do have these AML places, things in places with geofencing to prevent any misuse of this type of technology.
I see. So understand that. And basically, it's like because I did not see anyone ask question yet. So maybe this is the thing I will ask. Uh, at the beginning, you already talked about the how the finality of magic block very fast, right? 10 milliseconds is super fast. And I already read the white paper about the magic block. So uh, correct if I'm wrong. So basically, I know that's the ephemeral rollup. That is the clone of SVN, right? All of the logic about the account, all logic about the consensus, everything is the SVN. So basically, it's ephemeral rollup. So the question in here, because like the time is 10 milliseconds, so those magic block need to sacrifice about the centralized or not. Because like if if a magic block handle decentralized for every node to like handle the data to store, right? So maybe we need to have a consensus. But if have a problem about the time consensus, so maybe really the 10 milliseconds that is cannot guarantee every consensus. So yeah, so that is very I want to know about magic block. How
Yeah,
the how the 10 millisecond can handle that.
yeah, no, that's a great question. So for sure, there's definitely trade-offs in decentralization. It is a trusted process in the same way that I guess some of the more popular stuff coming up as well. So like Mega E for Atlas, it's like a trusted process, a trusted server. And there are a lot of good things about that actually in terms of when you sort of have these trusted sequencers, what you can do is that you can co-locate your sequencer with different projects. So given that it's trusted, say you know that most of your users are in Asia, you can place a sequencer in Asia and get the benefits of lower network latency as well. Actually, something really interesting with sort of these 10 millisecond block times that we're processing is that so one of Solana's fundamental innovations is the account model. And what that means is that at the validator level, when they're processing the transactions, they can see, for example, transaction A touches account A and B, and transaction B touches account C and D. They can see that these two transactions don't have any accounts overlapping, so they don't have to sequence it, right? It doesn't matter which comes first, which comes second. So they're able to parallelize a lot of these transactions. And interesting trivia is that right now, Magic Block is at around 3,000 to 4,000 TPS, and we actually right now do not even have that feature turned on. As of right now, we do not even parallelize these transactions in the same way that Solana does. And actually, once we turn it on later on this month, the TPS will expected to be going to like 20,000, 30,000, a 10x improvement. So all the benefits, like all our transactions, we have custom transaction processing logic. So even without this sort of core optimization of Solana, we were able to get 2,000 to 3,000 TPS. And this comes from, oh, sorry, go ahead.
Oh, no, sorry. I just wanted to add on what you said. But you're okay, Andy?
Yeah.
Oh, okay. Yeah, just also to add, Min, and also to answer your question here. So you were comparing like, okay, Solana decentralized, Magic Block, 10 milliseconds, 40 milliseconds, how does it work? Just for the audience also is Magic Block does not have consensus layer. So we are skipping all the consensus across the different validators, where you basically have to send the packages, verify, and we don't have that. So with that latency in terms of sending each other the vote, the transactions, the blocks, voting on it is just gone. So that's why it's just like really 10 milliseconds. It's the raw processing power to basically process a transaction and build the blocks. If you think about Alpenglow, which is like a new innovation that is coming up on Solana, which promises 100 milliseconds, and you could ask, okay, wow, that's great, 100 milliseconds. How does this affect Magic Block? If you look deeper in Alpenglow, it's an innovation on the voting and also the package sending, like to the other validators. So it's again consensus here. So they're improving like a lot on the consensus, which is great. Like from 400 milliseconds to 100 milliseconds, here's a 4x at least improvement. But since we took out the whole, it's like if you look at Solana now, you see Alpenglow like optimized consensus, and then you see the fully other extreme, which is Magic Block no consensus, right? We've really full processing on. You could say that in a centralized way. But that's where we kind of like have to trade off, similar to the other technologies like Mega ETH and so on. Annie was mentioning about. I think the difference also in terms of Mega ETH and Magic Block is if you look at how transactions are created and submitted, and what kind of hardware infrastructure you use. If you look at all these others, you have to use separate infrastructure. It's a different endpoint, right? You cannot submit the same transaction as you would submit it on Ethereum to Mega ETH, and that transaction will succeed. With Magic Block, you can do that, right? You have the same transaction, the data, the instructions are all the same, and you can submit it through our Magic Router, and the Magic Router basically as a single point, and which is basically also the existing infrastructure. We are not basically trying to create new infra, but we encourage to reuse existing infra and resources to kind of ensure that the decentralized infrastructure that Solana is providing is also being used, but with performance. So this, I think I wanted to highlight, like, is also the main difference.
I see. So basically, like no have consensus, so that is reason why it's fast. So here is the thing I am very considerate about. Like even like let's say I have dedicated account. So because have no consensus, right? So how the account can be backed up by the Magic Block? Because if have some problem about like server is like downsing something like that, and I need to redelegate. I need to undelegate that account into the main into base layer. So how the account is stored in the Magic Block because we have no consensus in here.
Yeah, so when you delegate, the owner of that PDA or this account that you are delegating is the delegation program. This is basically a lock mechanism to prevent any writes on that account. At the same time, while it's locked, it will be unlocked on the Ephemeral Rollup. So on the Ephemeral Rollup, basically you can submit transactions, and as all the accounts, program accounts and data accounts will be cloned on the Ephemeral Rollup, you can process the transaction as it is. If you want to undelegate it, what happens is the Ephemeral Rollup validator will submit a transaction to the program of the delegation program to basically change the owner back to the original owner, which is maybe your program, like the original program before. And that's how the unlock here works.
I think there is
To
have a niche,
elaborate, to
like
elaborate on that, if the
yeah,
ER goes down, we have a force quit feature of like you can always rescue your funds or rescue the state of the program past a certain amount of time, like on mainnet. So even if our say ER goes down, you can always rescue any accounts that you delegate to it.
I see. So, okay, I can like rededicate account to base layer, but the data of the account in the Ephemeral Rollups that is like still in the time that I delegate, or still the latest data, right? So that is the thing I'm very
So,
considered because like,
so that depends on whether you're committing. So we have this feature where you commit.
oh,
So then you
I
can
see.
make sure that, let's say, every 400 milliseconds, like every block Solana's producing, you have the latest data. So that's why we have this commit feature. So the best practice is not to delegate, do everything like for, let's say, 100 years, not 100 years, but let's say a year on the ER, and then you commit a year, take undelegated back. There will be a lot of risk within the 1 year. But if you always commit back, like let's say every 2 blocks, then you're just, or every block, then you will never miss the data, basically the latest date, since the ER is at least like 40 times faster, right? So that's why the ER exists, to make like these high performance precision, which results to high precision on the ER, and on ER on mainnet. I mean Solana, you have basically full HD, and on ER you have like 4K or 8K, like resolution of the state. Yes, that's how you can think about it.
It sounds good. Okay, so that is all of my
Yeah.
question. Like if like I did not see any question from the audience in here,
Yeah.
let's go ahead.
Yeah, in the interest of time, I can just quickly run through sort of a rundown on the TEE, and then see if we get any more questions by then as well. I don't want to take up too much of your guys' time either. So this is done. We don't need to go too close into this, but essentially this is the authentication layer of the ER. So how it works is that on mainnet, you have a program and there's a permission program. And so the program creates these permissions for groups, and groups are just groups of user accounts. It could be like, oh, for this group, I want Jonas and Min to be able to read and write to my program. And so within the private ER, this private ER will then read those permissions from mainnet and check to see whether the person trying to access the information has the permissions or not. And if it does, it will send the information to the client. And if it doesn't, it will block the access. So this is sort of a written form of that, where the flow is that the user authenticates with a signed message. So on your client, we didn't get to see it in the flow earlier, but on the client, the user signs a message to authenticate that this is my publicly using this client. So the TE checks the user and the signature and then shares a auth token. And so from then on, every request that you send to the ER will contain this auth token, and this auth token proves that you are who you are. And so upon the request, you check that the auth token is valid, you check the user permissions, and then it processes the request. So a quick sort of like implementation of this is that you just need to create a permission group on mainnet. And that's just as easy as making a CPI and creating a permission group. And this could all actually be done in one transaction, by the way. And then after you create a permission group, you just define the permissions for the group. So you can see you're defining the group here, you're defining like the permission, and then you're defining the accounts. So then just to finish up, I wanted to dive deeper into sort of our verifiable random function stuff. So I want you guys to understand sort of how these transactions are processed when users submit a verifiable random function. So how it looks is that first, your program does a request for randomness to the VRF program. And what this does is it adds this randomness request to a on-chain queue. Next, there's a network of validators working to fulfill this request. So this could be us, this could be you guys, this could be anyone working to fulfill the request. And we know that this validator is not cheating because when the validator fulfills the randomness request, it also needs to sign and submit a proof, a randomness proof. And this proof is then verified on chain through the randomness VRF program. And if the proof is valid, then the VRF program will call back into your original program that requested the randomness and letting you use the randomness however you want. And like I said earlier, just a lot of tricks you can do to sort of optimize this process. Like, yeah, using one shred of randomness for a lot of things at once, stuff like that. So how good is the VRF? So the VRF creates a random hash ID on chain when you're submitting. And this hash ID just comes from the slot number, slot hash, or Unix time, the callback inputs. And then it signs the random hash ID off chain to prove that what they were using to sort of seed the randomness that they generated was true, was what you submitted to them. And then posting this proof on chain, which is then verified by our VRF program, make sure that there's no sort of collusion that can occur here. Like in order, for example, the randomness program to even potentially be hacked, you would need to have collusion of like several different layers. You need to have collusion of the client, you need to have collusion of the program, and you need to have collusion of the Oracle as well. So it's essentially impossible for that to happen. But yeah, so then if you guys have any questions, like would love to hear them as well. And once again, my name's Andy. That's Jonas. Vincent Didi is not joining us with this today, but make sure to, if you guys are interested, click the QRs, follow us on X, join the Discord, and yeah, thanks for having us, Min. So then, do you have any other questions about TEE, about Magic Block, about life, anything?
I think it's like I have enough question. I also have received a lot of answers from all you guys. So yeah, so it's pretty good. So okay, because I did not see any question from the audience in here. So again, thank you so much, Andy, Jonas, to join the workshop for Twitter in Vietnam. We very super feeling good with the way handled Magic Club. I already said that, and yeah, hopefully have a lot of developers who will buildings with the Magic Club in the future.
Awesome. Yeah. Thanks for having us.
Thanks.
It was super
Thanks
great
for
to
having
meet
us,
everyone.
man.
Yeah.
Have a good one.
All right, bye-bye.
Yeah. Bye bye.